In today's hyper-connected world, data is being generated at an unprecedented rate. Businesses and organizations across all sectors are grappling with the challenge of managing this data deluge effectively. This is where the concepts of data lakes and data lakehouses come into play, offering a new paradigm for data storage and management. Data lakes and data lakehouses represent a significant departure from traditional data storage and management approaches. They signify a shift from rigid, schema-on-write systems to more flexible, schema-on-read architectures. This flexibility is crucial in today's rapidly evolving business environment, where new data sources emerge frequently, and the ability to adapt quickly is paramount. Imagine a vast sprawling lake fed by numerous rivers and streams, each carrying different types of sediment, minerals, and aquatic life. This, in essence, is the fundamental concept behind a data lake. Just like its natural counterpart, a data lake serves as a central repository, capable of storing massive volumes of raw data from various sources. The value proposition of data lakes extends beyond just storage. It lies in their ability to empower organizations with a more agile and cost-effective approach to data management and analysis. Data lakes, with their schema-on-read approach, eliminate upfront overhead, allowing organizations to ingest data quickly and worry about structuring it later. This agility is crucial in today's fast-paced business environment, where new data sources emerge constantly. To fully grasp the significance of data lakes, it's essential to understand their defining characteristics: flexibility, scalability, and the concept of schema-on-read. Flexibility allows organizations to store all types of data without the need for upfront transformations or schema definitions. Scalability is another hallmark of data lakes. As data volumes grow exponentially, organizations need storage solutions that can scale seamlessly. Data lakes, often built on distributed storage systems, excel in this regard, allowing organizations to store and manage petabytes or even exabytes of data. The story of data lakes begins in the late 2000s and early 2010s, marked by the explosive growth of big data. Traditional data warehousing solutions struggled to cope with this deluge of information, particularly the unstructured and semi-structured data. This challenge was particularly acute for web-scale companies like Google, Yahoo, and Facebook. They needed a new approach, a more flexible and scalable solution that could keep pace with their rapidly growing data needs. This led to the development of data lakes. Several key technological advancements contributed to the rise of data lakes. First and foremost was the maturation of the Hadoop ecosystem. Hadoop's distributed storage and processing capabilities made it an ideal foundation for building large-scale, cost-effective data lakes. Another crucial development was the emergence of cloud computing. Cloud platforms provided a cost-effective and scalable alternative to building and maintaining on-premises data centers. Cloud providers like AWS, Microsoft Azure, and Google Cloud Platform played a pivotal role in democratizing access to data lake technologies. By the mid-2010s, the concept of the data lake had moved beyond its early adopters in the tech industry and gained traction across a wide range of sectors. Organizations in finance, healthcare, retail, and manufacturing began to recognize the potential of data lakes to unlock valuable insights from their data assets. However, as data lakes became more prevalent, certain limitations became apparent. One of the most significant challenges was the risk of data lakes becoming data swamps. This issue highlighted the need for better data management practices, metadata management, and data quality control within data lakes. When it comes to data lakes, Amazon Web Services, or AWS, reigns supreme with its flagship storage service, Amazon Simple Storage Service, better known as S3. Launched in 2006, S3 has become synonymous with scalable, durable, and cost-effective object storage in the cloud. Its simplicity, along with its vast array of features and integrations, has made it the go-to choice for organizations of all sizes. One of the key strengths of S3 is its unmatched scalability. S3 automatically scales its infrastructure to accommodate your growing data needs, ensuring consistent performance. Microsoft's answer to the growing demand for data lake solutions is Azure Data Lake Storage, or ADLS. Tightly integrated with other Azure services, ADLS offers a comprehensive platform for building enterprise-grade data lakes on the Azure cloud. ADLS Gen 2 supports both hierarchical namespaces and the Hadoop distributed file system, making it easy to migrate existing Hadoop workloads to Azure. Google, a pioneer in large-scale data processing and analysis, offers Google Cloud Storage, a highly scalable and durable object storage service. With its focus on performance, cost optimization, and integration with Google's leading AI and analytics services, Google Cloud Storage is an attractive option for organizations. One of the standout features of Google Cloud Storage is its strong consistency model. This strong consistency model simplifies data pipelines and ensures data accuracy, particularly important for real-time analytics and machine learning applications. While the concept of a data lake holds immense promise, the reality often falls short of the ideal. Without proper management, governance, and a clear strategy, data lakes can quickly devolve into data swamps. Imagine our pristine lake now overrun with algae, choked with debris, and teeming with unidentifiable creatures. This is the image of a data swamp, a chaotic and unwieldy repository where valuable data lies submerged and inaccessible. Several factors contribute to this descent from data lake to data swamp. One of the primary culprits is the store-everything mentality often adopted during the initial implementation phase. One of the key contributors to the proliferation of data swamps is the lack of robust data governance. Data governance encompasses the policies, procedures, and controls that ensure data quality, integrity, security, and compliance. Without a well-defined governance framework, data lakes can quickly become the Wild West of data management. Establishing clear data ownership is crucial. Every data set within the data lake should have a designated owner responsible for its quality, accuracy, and accessibility. Building and managing a successful data lake requires a skilled and experienced crew. Organizations often underestimate the technical expertise needed to navigate the complexities of data ingestion, storage, processing, analysis, and governance. Data engineers are essential for building and maintaining the infrastructure of the data lake. They need expertise in distributed systems, cloud computing platforms, and data integration tools. Data scientists are crucial for extracting insights from the data and driving data-driven decision-making. They require strong analytical skills, statistical knowledge, and proficiency in machine learning algorithms and tools. The Data Lakehouse represents a sophisticated solution to bridge the gap between the flexibility of data lakes and the structure and governance of data warehouses. Picture a modern architectural marvel, seamlessly blending the expansive openness of a lake with the organized functionality of a well-designed house. This is the essence of the Data Lakehouse, a unified platform that harmonizes the strengths of both worlds. The concept of the Data Lakehouse gained significant traction in response to the challenges encountered with traditional data lakes. Data lakehouses address these shortcomings by incorporating key features of data warehouses, such as schema enforcement, data quality management, and transaction support. This ensures that data, even in its rawest form, adheres to certain standards and remains consistent and reliable for analysis. A data lakehouse is more than just a clever name, it's a powerful concept backed by a unique set of features. These key features are designed to address the shortcomings of each approach while amplifying their strengths. One of the defining features of a data lakehouse is its support for both structured and unstructured data. Data lakehouses introduce elements of schema enforcement and data quality management, ensuring that data remains consistent and reliable for analysis. The architectural advantages of a data lakehouse translate into tangible benefits for organizations across industries. By merging the strengths of data lakes and data warehouses, data lakehouses empower organizations to unlock the full potential of their data. One of the most significant benefits is improved agility and speed. Data can be ingested from various sources and made available for analysis in its raw format, enabling organizations to respond to changing business requirements with greater agility. The emergence of the data lakehouse has shaken up the world of data management, prompting organizations to reevaluate their data storage and processing strategies. To fully appreciate the value proposition of the data lakehouse, it's essential to understand how it differs from the traditional data warehouse. Data warehouses, often described as schema-on-write systems, operate on the principle of structure and predefined schemas. Before data can enter the warehouse, it must conform to a specific structure, ensuring consistency and facilitating efficient querying and analysis. This structured approach makes data warehouses highly effective for structured data and supporting business intelligence applications. As we've journeyed through the evolution of data storage and management, from the early days of data lakes to the emergence of data lakehouses, one thing has become abundantly clear: the ability to harness the power of data is paramount in today's data-driven world. Data lakehouses, with their unique blend of flexibility, scalability, structure, and governance, represent a significant leap forward in our quest to unlock the transformative potential of data. They empower organizations to break down data silos, foster collaboration, and gain a deeper understanding of their operations, customers, and the competitive landscape. The traditional boundaries between data lakes and data warehouses are blurring, paving the way for a more unified and agile approach to data management. Data lakehouses, with their ability to seamlessly handle both structured and unstructured data, provide a future-proof solution for organizations grappling with the ever-growing volume, variety, and velocity of data. They enable organizations to move beyond the limitations of siloed data architectures, where data is often trapped in disparate systems, hindering collaboration and slowing down decision-making. The data lakehouse is not a distant vision of the future, it's a reality that organizations across industries are embracing today. The technology has matured significantly in recent years, with robust solutions available from leading cloud providers and open-source communities. Organizations that are serious about harnessing the power of data and gaining a competitive edge cannot afford to ignore the transformative potential of data lakehouses. The journey towards adopting a data lakehouse architecture begins with a clear understanding of your organization's specific needs, challenges, and long-term goals. A well-defined data strategy, coupled with a thorough assessment of your existing data infrastructure, will guide you in determining the optimal approach, whether it's a full-fledged data lakehouse implementation, a hybrid approach integrating with existing data warehouses, or a phased migration strategy. As we venture further into the data-driven future, the role of data will only continue to grow in importance. Organizations that can effectively collect, manage, analyze, and act upon data will be the ones that thrive in the years to come. Data lakehouses, with their ability to unify, govern, and unlock the value of data, will play a pivotal role in shaping this data-driven future. However, the journey towards a data-driven future is not without its challenges. The increasing volume and complexity of data, coupled with the evolving regulatory landscape, will continue to test the limits of our data management capabilities. Organizations will need to remain agile, constantly adapting their data strategies and technologies to keep pace with the ever-changing data landscape.